Good morning, Tehmina Khan is here in TK Maths is Fun. In today's video, we will continue the lessons on M1, which is part of the syllabus of A-level mathematics. And now this lesson will be on use of calculus. In the previous video, rather I would say in 8 videos, we covered the concept of distance, velocity and acceleration. As this is the series of the complete understanding of the subject M1 of mathematics. So in this lesson 3, we will cover use of calculus. So the main points are acceleration as a function of time, velocity as a function of displacement, acceleration as a function of displacement, acceleration as a function of velocity. So we will see here the use of differentiation and integration, and there will be only 2 videos which will cover the concept because it is a small concept, and prerequisite knowledge is that you should know how to differentiate and how to integrate. So let's see in which case we differentiate it, right? So first of all, if you look at this sketch, it is about position and time, or you can say about displacement time or distance time. In these graphs, when you look at the gradient of the curve, that gives you basically what? Velocity, right? So what did we get from here? That rate of change of the position is the gradient of the tangent to the curve. And by differentiating, you are getting here what? Velocity. So it means if you are given displacement equation and you differentiate it, you get the velocity equation, right? I will take one example in which I will explain all this, but right now you need to understand theory also. Now you have a velocity time graph, okay? And if you take the gradient of it, what will you get? Acceleration, right? So if you have a velocity equation and you differentiate it, you get the acceleration if you look at this. But what about the connection between A and this? Absolutely right. When we differentiate first time the displacement equation, we get what? Velocity. And we differentiate the velocity equation, we get what? Acceleration. In other words, we differentiate the displacement equation 2 times, right? Now let's see this example. An object moves along. Now right now I'm talking about with respect to what? Differentiation. So if velocity equation is given and you have to find accelerated equation, then you will differentiate it. Or if displacement given, you have to find velocity, you will differentiate. So this example is only related to this aspect. An object moves along a straight line so that its position, now this is a straight line, right? Object is moving like this. And this equation is giving its position at different points with respect to time, of course. Find an expression for the velocity and acceleration of the object at time t. So what does this mean? Very simple. You just have to differentiate this equation 2 times. One time to get the velocity equation and the other time to get the acceleration equation. Now here I have already solved it and changed it into numerical form. So you can put the video on pause and differentiate yourself to see if your prerequisite knowledge is very clear, because differentiation you should know at this stage, right? In case if somebody has forgotten, just very quick recap. If this is your equation, any equation, and you're differentiating it, what do? You multiply by the power and subtract the power by 1. This is how you differentiate it. Now you have to get the acceleration equation. So what will you do? You will differentiate it one more time. The next part of the graph is saying, a question is saying, find the values of x, v and a when t is 0, 1, 2, 3. So I think this is simple. You just have to substitute these timing in these equation. So in the tabulation form it is easy to do. So here it is done for you. Sketch the graph of x, v and t against time. So now using these values and using these equation, you will sketch it. Now one thing, the first equation which is about position or displacement, it is basically cubic equation. and the coefficient of t cube is positive. So again, the prerequisite is when the coefficient of t cube is positive, the cubic equation will have graph like this, but within only the values given in the table. And quadratic equation has graph like this. And acceleration, straight line, so graph like this. So without even plotting, at this point I know what is the shape of the curve, but it may not be exactly like this, maybe part of this, maybe part of this. Why? Depending on the values. T cannot be negative now. So when we are plotting, we will not plot anything on this side. Our x-axis will be t-axis and y-axis will be x, v and a, right? So let's see the sketch of these against these values which we have plotted here. So first of all, the position graph. So the main points are 0, 1, 2 and 3 on the x-axis. So you can see 0, 1, 2 and 3. So points have been marked against these and it is plotted here. Next part of the graph, the question is saying describe the motion. We will do it later. So first of all, let's see the sketch of these type of graphs. Okay. So now I am doing here velocity time graph. Again, it is on 0 value, 1 value, 2 and 3. So we have simply plotted the point and we have sketched the graph. I will discuss it in a while. First of all, I'm just showing you here the sketch because this is very, very important sketch. It gives you very important connection between all three. Now it is equation, by the way, is written here for your reference if you want to see. Now for acceleration, 12t. So again, for time 0, time 1 second, 2 second and 3 second. Now let's see its interpretation because the last part of the question is interpreted. Okay, before I show it to you, what comes in your mind when you look at this graph? Just focus on the position time graph. It was told in the beginning that object is moving on a straight line. So what do you understand? What is happening here? Suppose this is the time 0 and s0, right? This is the position. So what happened? Yes, here what is happening? Object is going in this direction, right? And then what happens here? Instantaneously at rest. When the object is instantaneously at rest, it will take about turn, right? So now object will start moving back in this direction. And you can also see the gradient here is negative. We know that, again, it is a prerequisite knowledge. When the line has this flow, it is negative gradient. This flow, positive gradient, right? So now for all the part of the curve from here to here, it is positive gradient. Flow is in this direction now. So let's see the description here. Let me make it little clear also here. Okay, so the object starts at the origin, here it is, towards the negative direction. This is what I told you. Initially it was going in this direction, gradually slowing down because you can see it is like this, right? If it is like this, it is increasing. But if it is like this, it is slowing down. Okay, now what? What is the connection between velocity time graph and position time graph at this point? This is instantaneously stop. When it is instantaneously stop, it is at v0 at time 1 second. Now what is this point here? When you put t0 here, v is equals to -6. So this shows at t equals to 1, it stops instantaneously and changes direction. I told you object took about turn from there, right, to its initial position at about t is equals to 1.7. Now this 1.7 is not mentioned here, right? Here at t is equals to t 1.7 here, it is not showing here because if you put in the position time graph, in this graph, let me show you here, x is equals to 2t cube minus 6t. And now if position is 0, because when it is coming back to its initial position, So it will be t equals to 0 or t equals to root 3, and root 3 is 1.7, and that's why this point is 1.7, which is mentioned here. Okay, when object is back to its initial position here, it is started from here, so when it comes back here, the time is 1.7 second. At times it is asked, right? And then after that it is just moving on and on. But with respect to velocity time graph, from 0 now it is going in this direction. Earlier it has negative velocity and now it has positive velocity, right? Now what happened after that? It then continues moving in the positive direction and increasing speed. So we can see, because it is a curve here, it is increasing speed, right? I'm just cleaning it again so that everything is neat. Okay, now let's see this one, last one. The acceleration is increasing at a constant rate. This cannot go on for much longer or the speed will become excessive, because no end limit is given, nothing. So that's why we are only plotting till t is equals to 3 seconds. And gradient is equals to 0. Which point? At this point. And that's why it is starting from here. Right. So now I hope you understood the connection between them. So now the last part is about using integration. This we will cover in the next video. So I hope you understood. Thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.